You've probably lost something to someone less qualified than you. A promotion, a deal, a spot on a team. You had the skills. They had the connections. It feels unfair, it feels small. But the real answer to why this keeps happening to humans is far stranger than office politics. It happened once before, on a planet-sized scale, to an entire species of humans. And for decades, nobody could explain why. 200,000 years ago, Europe belonged to the Neanderthals. Thick-boned, barrel-chested, built for cold. Their brains, on average, were slightly larger than yours. They made tools. They controlled fire. They buried their dead. For over 300,000 years, they thrived on a continent that would have killed almost anything else. Then, around 40,000 years ago, they vanished. Not slowly, not gently. Within a few thousand years, one of the most successful human species in history simply stopped existing. And for a long time, the explanation seemed obvious. A smarter, more advanced species showed up. Homo sapiens. Us. We were sharper, we were better, we won. That story felt satisfying. It also turned out to be mostly wrong. Chris Stringer, one of the world's leading paleoanthropologists at the Natural History Museum in London, has spent decades studying Neanderthal remains. His research kept circling back to an uncomfortable fact. Neanderthals weren't primitive. Their toolkits were sophisticated. Some evidence suggests they made jewelry, used pigments, and cared for injured members of their group well past the point of usefulness. This wasn't a lesser species standing in your evolutionary shadow. This was a peer. So if intelligence didn't decide the outcome, what did? The first real crack in the mystery came from inside our own bodies. In 2010, a team led by geneticist Svante Pääbo sequenced the Neanderthal genome for the first time. What they found rewired the entire story. Most people alive today outside of sub-Saharan Africa carry a small percentage of Neanderthal DNA. Somewhere between 1 and 2% quietly sitting inside your own genetic code right now. That means Neanderthals didn't simply lose to modern humans. They merged with them. Interbreeding happened, repeatedly, across thousands of years and multiple regions. So the extinction wasn't a clean replacement, like one team beating another and walking off the field. It was something closer to absorption, a slow dissolving of one population into another, generation after generation, until the distinct group quietly stopped being distinct at all. But that still leaves a question hanging in the air. Why would one group dissolve into the other, instead of the reverse? Why didn't modern humans get absorbed into the much larger, well-established Neanderthal population instead? This is where the story stops being about brains and starts being about numbers. In 2019, researcher Chris Vason and colleagues ran computer simulations modeling Neanderthal population dynamics. The results were almost anticlimactic in how simple they were. Neanderthal groups appear to have been small, tiny in fact, compared to the sprawling, interconnected networks of early Homo sapiens. Some estimates put the total Neanderthal population across all of Europe and Asia at any given time in the low tens of thousands. Scattered, isolated, spread thin across an enormous landscape. Small populations are fragile in a way that has nothing to do with intelligence or strength. Fewer people means less genetic diversity, and less genetic diversity means less resilience against disease, bad seasons, and simple bad luck. A single harsh winter that a large, interconnected population could absorb might be catastrophic for a small, disconnected one. Run that math forward for a few thousand years, and the odds stop favoring survival at all. Now, compare that to early Homo sapiens. Archaeological evidence suggests they weren't just spread across the landscape, they were connected across it. Trade networks moved shells, ochre, and tools hundreds of kilometers from their origin. Groups that had never met were still, in some sense, in contact. Information moved. Innovations moved. If one small band figured out a better way to trap prey or treat a wound, that knowledge had a path to travel outward instead of dying with the people who discovered it. Neanderthals, by most current evidence, didn't have that same reach. Their groups stayed smaller and more isolated. Not because they were incapable of connection, but because the terrain, the climate, and the sheer distances between viable settlements worked against it. Here's the part that should sit with you for a second. This wasn't a war. There's very little evidence of large-scale violent conflict between the two species. There's no ancient battlefield, no genocide etched into the bones. What actually happened looks less like a fight and more like a slow demographic squeeze. More people, more connections, more redundancy against disaster. That is what tipped the scale. Rebecca Ragg, Sykes, an archaeologist who has spent her career studying Neanderthal life, has pushed back hard against the old idea that they were lumbering, doomed failures waiting to be replaced. Her research paints a picture of a species remarkably adapted to a brutal environment, resourceful and resilient in ways science is still cataloging. Their disappearance wasn't a verdict on their worth. It was a numbers game they were never positioned to win. So which theory is correct? The interbreeding or the population collapse? Increasingly, the evidence suggests you don't have to choose. These explanations layer on top of each other instead of competing. Small, isolated Neanderthal populations were vulnerable to collapse. As modern human numbers grew and their networks expanded into the same territory, contact between the two groups increased. Some of that contact was competition for the same resources. Some of it, unmistakably, was reproduction. Over generations, the smaller population didn't get wiped out so much as folded into the larger one. Its distinct identity gradually diluted until what remained was scattered fragments of DNA inside a different species entirely. Is that extinction, or is it something closer to a slow merger nobody signed up for? Think about what that actually means. Neanderthals didn't lose because they were unintelligent. They didn't lose because they were weak. They lost because they were outnumbered and underconnected, in a world where the size and reach of your network mattered more than almost anything else. Strength alone couldn't save a species that stayed small while its neighbors kept growing and linking together. That should sound familiar. Because it's still happening right now to you. The best idea in a meeting doesn't always win. The most talented person doesn't always get promoted. The strongest argument doesn't always spread the furthest online. What tends to win is connection. Reach. The size of the network carrying an idea forward. Your brain evolved inside a species that learned this lesson 40,000 years ago, watching a genetically similar, physically formidable cousin fade into the background simply because it never built the same web of connections. You've probably lost something to someone less qualified than you. Maybe now the answer feels a little less unfair and a little more familiar. It isn't really about who deserves to win. It never was. It's about who's connected enough to survive the next hard winter. And somewhere in your own DNA, quietly, a small percentage of an ancient answer is still waiting to remind you of that.